Yes.
Or are you still covering new material?
Well, right now we just have one more unit left, which is quadratic formula.
Okay. So is that what we're doing tonight, or that next time?
Yeah, that's what we're doing today.
Okay. So, give me a problem.
All right. Here's one.
One.
2x squared.
Okay. You say 2x squared?
Yeah, 2x squared minus 11x plus 14 equals 0.
Okay. I'm going to presume that we cannot factor this.
Mm-hmm.
And I'm also going to presume that the instructions say use the quadratic formula to solve it.
Yeah, it does.
Now, you can use the quadratic formula to solve quadratics that can be factored also.
Mm-hmm.
In other words, the quadratic formula works on everything. You're going to come across a lot of situations where they won't tell you to use the quadratic, and you can waste about a minute trying to factor it until you discover it can't be factored, and then you go to the quadratic formula. But in this particular case, since they tell you to use it, first of all, what is it?
Negative b plus minus square root of b squared minus 4ac over 2a.
Good. And in our case, what is A, B, and C?
A is 2, B is negative 11, and C is positive 14.
Okay, let's plug it in.
Alright, so it would be 11 plus minus 121 minus 4 parentheses 2 parentheses 14.
And all over?
All over 4.
Okay.
Or 2 parentheses 2.
Yeah, no, it's okay to do that one in your head. I do highly suggest that your next step is always figuring out what that number is right there. You're going to be faced with quadratics where there's a lot of negative signs. Let's say C was negative 14.
Mm-hmm.
Now it can get very confusing. For one thing, the first negative sign is subtraction. The second one would be a negative sign. So what I do myself whenever I'm doing these is I always figure out what the 4AC part of it is.
Mm-hmm.
And then I subtract that from 121. And if it is a positive number, then we have real solutions. If 4AC is bigger than the b squared, then you're going to have a negative number in the radical.
Mm-hmm.
And that is what gives you imaginary solutions. Imagine that they've taught complex numbers to you.
What is that?
Imaginary numbers?
No.
Not yet? Okay. Well, it'll be coming shortly because a lot of times you get a quadratic that doesn't give you real solutions. It only gives you imaginary ones. And imaginary doesn't mean it's not meaningful, but it's not a real number. So what's 4 times 2 times 14?
It'd be 28 times 4. Hold up. I don't have a calculator with me.
Okay. I would do it 8 times 14, just because single digits are easier to multiply.
Mm-hmm.
Okay. So that's 112. 121 minus 112 is 9. So what are our two answers?
It would be, the first one would be 14.
Over 4.
Or 14 over 4, sorry. So that would be...
2. And what's the second one?
Yeah, 7 over... the second one would be... 2.25.
Give it to me as a fraction.
So that would be 9 over 4.
Actually, it's 8 over 4. In other words, we're going to replace that with a 3, right?
Right.
The second one is 11 minus 3, which is 8.
Oh, yeah.
Divided by 4, so it's a whole number.
Right.
Now, this is kind of interesting. What it really means is that we actually could have factored it with those two results, but it's hard to factor something like that into fractions. So the quadratic formula was probably the easier way to do it.
Mm-hmm.
Or actually, I could even change this to 2x minus 7 times x minus 2, I suspect, gives us this quadratic. Yeah, it does. In other words, I could have factored it. Not this way, but this way right here. If you FOIL those two back together again, you get this quadratic, and this is what represents that solution. This one represents that solution.
Mm-hmm.
Okay. I think you're pretty good on these. Do you have any other subjects other than quadratics? I mean, we can work on those if you need to, but I don't see you making a mistake, but maybe. I don't know. You subtracted 11 minus 3 wrong, but
Yeah.
that's not usually where the mistakes are made. Maybe we should try one more. Just
Okay.
seem to be all over it, but
It would be, here's one. 2x squared plus 9x equals 0.
and they specifically want you to use the quadratic formula?
Yeah.
Good. Tell me what A, B, and C are, because we wouldn't need to at all on this one. I can factor out x as a greatest common factor, and then I got one thing multiplied by another equals 0. It's easy to solve.
Right.
However, it's a good demonstration as to what are A, B, and C when it's not obvious. What's A?
2,
B?
9,
C?
0.
Okay. So, x equal what?
X equals -9 plus minus 81 minus 4
Don't forget
parentheses
the
2.
square root.
Oh, yes. Square root 81 minus 4 parentheses.
Right.
2 and then 0.
So that immediately wipes that out.
Mm-hmm.
All over 4. And what are our two answers?
They would be...
So what's square root of 81?
Square root of 81 is 9.
Okay, so let's cross that out and replace it with a 9. Now do minus 9 plus 9 divided by 4.
Yeah, so that'd be 0.
And do minus 9 minus 9 divided by 4.
That'd be 18.
It would be minus 18 fourths.
18. What? Where'd you get? Oh, the divided by 4, yeah.
Okay, and then that's going to simplify to minus 9 halves.
Uh-huh.
So those are our two solutions. Notice that if I factor it, I immediately get this. Boom. Much easier to get our solutions. There's our 0 solution. There's our minus 9 halves solution.
Mm-hmm.
So you kind of only want to use the quadratic when you have to. But like I said, sometimes you can't tell by looking at a quadratic whether it's factorable or not. And I've had problems on timed tests where, you don't want to spend a minute trying to factor it and then realize you can't do it. And now you got to do the quadratic. It's a wasted minute. So if you suspect that it's going to require the quadratic, it's best to just plow into the quadratic, especially if you know it as good as you know it.
Mm-hmm.
Not everybody knows it as good as you know it, but if you do, then I would just go ahead and go for it immediately. Depends on how good your factoring is. Sometimes you can look at something and you can know that it's not factorable. If I give you this problem right here, there are no factors of 15 that subtract to the number 1. I can see that instantly. You got 5 and 3, that subtracts to the number 2. So the moment I see x squared minus x minus 15, I know it's not factorable. I'm going to use the quadratic formula instantly. If I have to figure out those zeros. So, what else? You got anything besides quadratic formula?
There's like you could use the method on the test and get like extra credit. It's called like completing the square, but like I don't really know
Let's
it.
do one of those. I want to teach you how to complete the square. That's an important skill in algebra. If you don't know how to do it, let's do it. It's not really that hard.
Okay.
Do you have a problem?
No.
I can make one up. First of all, let's start with, what's the vertex format for a quadratic?
Parentheses, I think it's...
Well, there's an A in front, and then there's...
Yeah, A. And then it's like, is it B?
It's H.
It's H.
H and K. Where H and K are your vertex.
Okay.
There's numbers for H and K, and that's where your vertex is. So this is a really valuable format. If you can get it into vertex format, then you can graph it really easily. So I'm going to give you one and show you how to take something that's in standard format and put it into vertex format.
Okay.
And just make sure that that does not result in a... Notice we cannot factor that. And by saying notice that we can't, what I'm noticing is that there are no factors of 10 that add to 6. And that's what we would need in order to factor it. We would need factors of 10 that add, because of the plus sign in front of the 10, to the number 6.
Right.
So I can't factor it, so I can't put it into x-intercept form, but I can put it into vertex form by completing the square. And this is how you do it. first of all, you group your x squared term and your x term together. Leave enough space to add a number. Notice I have not changed anything. I've merely put parentheses around the first two terms.
Mm-hmm.
Now, the process of completing the square is you take half of the coefficient of the x term and square it. What's that? Take half of 6.
I'm confused.
Take half of 6
Okay, it's 3.
and square it.
Alright, so 9.
What's 3 squared?
9.
Always add that number.
Okay.
Now, I can't arbitrarily add that number without changing the equation. However, I can do it if I put a minus 9 over here. Now, notice what I did. I added 9 to the right side of the equation, and I subtracted 9. Well, that doesn't change anything. In other words, that bottom row that you're looking at is exactly what we started with. The advantage of doing it is because I completed the square, I'm now able to write this thing as a linear term squared, which is this format. I add my two numbers together, I get plus 1. What's h and what is k?
H is -3.
Oh, remember it's x minus h. It's always x minus h. It's never x plus h. And it's never y plus k. Notice that this k actually started out on the other side of the equation where it was y minus k. It only became plus when I moved it to the right side of the equation. So no matter what you're dealing with, whether it's quadratics, conic sections, it's always x minus h and y minus k. It's never x plus h. And that being the case, what is h?
H?
Based on this. What's my...
Well, how do I know what X is, though?
You don't. I didn't ask you about X. I only want to know what H is.
Right, but...
It's positive 3.
Okay.
It's not negative 3. It's positive 3. And what's K?
K would be positive 1.
Yeah. And now, the fact that I have it in vertex format, that's a big head start on graphing it. I know that I'm going to start right there. Am I going to go up or down? I'm going to go up. So I can tell a lot once I can get this. This is standard format. Well, I gave it to you in standard format. Not so easy to graph that. But once I complete the square, it's in vertex format. And now very easy to graph. So that's merely one of the uses for completing the square. There's some others. There's actually a lot of uses, but it can get a little bit more complicated. Let me give you one. Now, I don't know if this is factorable or not. Not that that necessarily makes it easier. Completing the square, once you get it down, is actually pretty easy. Okay? However, this is slightly different. Okay? I'm going to put parentheses around there, like that. but I cannot complete the square until I get the coefficient of the first term to be 1. So how do I do that? In other words, the whole process of completing the square requires that. This cannot be a 2. Has to be a 1. How can I make it a 1?
Would you divide everything by 2?
Yeah, factor out a 2. Now what are you left with? X squared minus 5x. I'm going to leave space to complete the square. And I still have my 5. Again, when you're doing these, the most important thing you can do is make sure you don't change anything when you go from one line to the next.
Okay.
Okay? Now, how do we complete the square inside the parentheses? We got our coefficient to 1. This, incidentally, is a. Remember in the vertex format, it's y equals a times x minus h squared plus k. So that 2 that we factored out becomes my a.
Okay.
Okay, how do I complete the square? And you're always adding, you're never subtracting, so I'm going to go ahead and put a plus sign there. Take half of the middle term's coefficient and square it.
Okay, so...
Hold on, let's make it just a little bit easier. I'm going to change that to a 12. I'm going to change this to a 6. Okay? Now let's do it where we don't have to invoke fractions. I don't want to make it more confusing.
Alright, so would it be 30, would it be 9, I think?
In other words, you took half of 6 and squared it. It doesn't really matter whether it's minus 6 or plus 6. Once you take half of it and square it, you're getting a plus number. Now, how do I balance it? Because I just wrote in 9. Can't just arbitrarily add numbers to the right side.
You have to minus 9.
Well, actually, how much did I add to the right side of the equation when I put that 9 in there? What's that 9 being multiplied by?
18. 2, so it'd be 18.
Uh-huh. So to balance it, I have to subtract 18. Now this row is identical to that row. And furthermore, I can write it as what? 2 times, remember, it should look like x minus some number squared. This is minus 13 over here when I combine those. So what is it going to be? X what? First of all, is it a plus or a minus?
It's a minus.
Yeah, because of that minus right there. What's the number?
Would it be like, I don't know.
What number did you get when you took half of 6?
3.
That's always the number.
Oh. Okay.
Whatever you got when you took half of that middle coefficient, that's what goes there. Notice that if I FOIL x minus 3 times x minus 3, I get that x squared minus 6x plus 9. In other words, the whole purpose of completing the square is so that you can write it as a single linear term squared. The x minus 3 being the linear term. In other words, I'm not writing it in a quadratic form really anymore. Well, it's in vertex format, but that's a linear term right there. That's the whole thing squared. And now I know everything. I know what A is, the vertical stretch factor. I know shifted 3 units to the right, shifted 13 units down. My vertex is where? What's H and K?
It would be 3 and negative 13.
Good. In other words, you do carry that sign, whatever it is, plus or minus, but this is kind of the opposite. If this says minus 3, then it's always 3. It's the opposite sign of what it's connected to the 8x by.
Right.
All right. That's completing the square. And sometimes you will run into problems where when you're completing the square on the left side, there's a number on the right side of the equation, and you have to add the same amount to the right side. Sometimes completing the square is like we did tonight, where you're adding a number to the right side, you have to subtract the same number from the same side. But when you get the conic sections, it'll be different. You'll be adding a number to the left side to complete the square, and then you have to add the exact same amount to the right side to balance. You can just never, that's the thing always to keep in mind, is that all you're doing is algebraically manipulating it so that you take standard format and put it into vertex format. It's got to still be the same function. You can't change the function. All right. Blake, let you go. I think we're doing a session tomorrow night, right?
Yep.
Talk to you then.
All right, thank you.